I'm here today with Bob Beachler, who's a VP of product for Untether AI. And Bob is a seasoned product development and marketing leader from Silicon Valley with a deep semiconductor experience, hailing from some of the industry giants like Altera and Exar and Xilinx, and also has experience guiding startups like BrainChip and Analog Inference. He has an amazing track record of success in developing some of the industry first products, ranging all the way from FPGAs to vision processing and AI acceleration chips. So you currently are leading a product at Untether, and I've been following your work in Untether for quite some time. As you know, we've been able to run into each other at a number of conferences, and many moons ago, Bob Grimm from Tensor initially introduced us to each other, and we've been able
Yep.
to enjoy some insightful conversations since. So I couldn't be more thrilled to have you join us today. So without further ado, welcome, Bob.
Thanks for having me, Justin. And that's a glowing review. I really appreciate it. Um, I never read your press releases, so stay humble.
Absolutely. Well, to kick things off, if you can get us started, for anyone who doesn't know of Untether, maybe unfamiliar with the work, can you give us an overview of what you're building?
Sure. So we make a general purpose AI inference acceleration chip. So what makes us kind of unique in this regard, you have NVIDIA with their GPUs, but they really now have data center class GPUs that are really focused on AI acceleration for training. Um, and then because all of the models are trained on NVIDIA, they can obviously inference them as well. We're pretty unique in that we're analogous to that, but we focus on inference, which allows us to do some optimizations. And we've developed a kind of a novel compute structure that allows us to do inferencing faster, cooler, and more cost effectively. And so that's really what we're all about. We're a general purpose accelerator.
Okay. Well, and you've mentioned a number of segments within the AI space, and it's evolving very, very rapidly. Can you give us some insight into an emerging AI trend that you see around the corner that others may not?
Yeah. Well, I'd like to think that our foresight is a competitive advantage, so that right, and predicting where the puck is going to go, as Wayne Gretzky would say, is part of what you do as a product leader. But a couple of things that I see is that general purpose AI acceleration. So yes, there are some fixed, function focused activities. You're seeing vision chips with some 50 tops of an NPU, and that's going to be in like a security camera. Or you see people saying, well, I'm going to focus only on stereoscopic vision. But what I find is that that's so nichey, and that if you don't hit it right on, then you have problems in terms of market acceptance. We look at our solution as a scalable solution from kind of what we call the heavy edge to the data center. And because we're seeing hundreds of models coming out every month. I mean, we've literally gotten hundreds of models from our customers saying, I don't want to run this specific model. I've done my own riff on it. I've changed the architecture a little bit. And understanding that and making sure that you keep your architecture optimized for inference acceleration, but flexible enough so that you can adapt to what's going to happen in the future, is really important. So if you look at the overall AI landscape, back in the day, just 10 years ago when CNNs first started out with AlexNet at the University of Toronto, right, everything was convolutional networks. Then we got to natural language processing and transformer style networks. Then we started seeing large language models. Then we started seeing vision transformers, where we're taking, instead of doing CNNs for vision, we're using transformer style models for vision. So if you were looking, 4 years ago, 8 years ago, and said, I'm going to make an AI acceleration solution, you make it CNN, you're obsolete now. So understanding that is pretty important. The other thing that we see, and why we're focused on inference, is we kind of feel that the training wars are over, right? Training happens in the cloud, because it takes so much compute and you need such a scale out. NVIDIA does 98% of the training in the world. I mean, certainly there's Google TPUs, there's Amazon has their own chips. Microsoft is making their own chips. But that's where the training happens. But inference is going to happen everywhere. It's going to scale from the endpoint, like I said, even in these little cameras with 50 tops to, what we provide, like a 2 peta-op card or a 8 peta-op card, and then into the data center. And so that's also something that we see and what we focus on is making sure we have a scalable solution because inference is going to happen everywhere and training is going to be in the cloud.
Absolutely. Well, and you mentioned flexibility being key as well. And speaking of flexibility, the last time we actually saw each other was in Toronto. But then before that, it was nearly a year or so ago, and you had a different CEO. What has Chris Walker done to help advance the vision that you're speaking of?
Yeah, so what Chris brings is really a large company production scale mindset. As we transition from being a development company to being a delivery company, right? So, we've just now started sampling our second generation chip. We had our first generation chip that proved out our at memory compute architecture. But now we're ready to transition to that next level, which is it's not about just developing a technology, it's about delivering it at scale to customers. And so in that aspect, that's kind of what Chris brings with his experience, obviously running one of the largest groups at Intel in the client compute division.
Absolutely. Thanks for that insight. And speaking of Toronto, you shared the stage with Andrew Feldman, the CEO of Cerebras, and you guys spoke about the arms race, the AI arms race that is currently underway. In your view, what must an AI hardware company do to not only survive, but to thrive in this competitive market?
Sure. Well, I think there's two aspects. One is on the financial side, which is it takes a lot of money. So you have to raise money. You have to have strong, deep-pocketed investors that are willing to understand that this is not a sprint. This is a marathon. This is not I start a company and I flip it and IPO in 2 years. You've mentioned Cerebras and Andrew Feldman. So they filed to go public. They've been working on this for 7, 8 years now, and $600 million raised. It's not cheap. So having that financial backing is key. Like what we have, Intel Capital has been a lead or co-lead in every one of our rounds, and it's not just their money, but it's their strategic advice and direction that helps us. Also having strategic like General Motors and GM Ventures, so that we understand for some of our target markets, we get real good insights into what are the key care abouts there. So that's on the financial side. And then on the product side, obviously what I mentioned, general purpose. You can't be a one-trick pony. Yes, we are involved in automotive. We're also involved in data center, and we'll talk about that perhaps in a minute. There's some pretty exciting news today. So you want to have a broad market footprint because any given market will run at its own pace. And then the continuous improvement. It's not one and done. As I mentioned, we're already, shipping now, sampling our second generation chip. And the announcement we had today was a company called Ola Kutrum in India, where they've selected us to work on their next generation data center chip. That's our third generation. So while we're just now sampling our second, we're already involved with a definitional customer on our third. And so those are the types of things you need to do.
Congrats on that news. That's awesome. So they're currently somewhere between 200 and 210 companies worldwide working on AI hardware. How is Untether's solution differentiated, and how does that enable you to stand out in a very crowded market, Bob?
Yeah, sure. So at its base, what we do is unique and different. Most of the architectures out today are a RIF or a slight modification of a von Neumann or near memory architecture, where I have external memory, I have caches, and then I have my data processing in a pipeline. We turn that completely around, where we want to put the processing directly attached to where you store the memory. We call this at memory compute. So it's a unique, highly differentiated architecture that gives us tremendous energy efficiency, throughput, and low latency. However, the reason that nobody's done it before is that it presents some challenges from a compilation standpoint. Because it's a spatial architecture, meaning we have tens of thousands of threads of compute all running simultaneously, which is what you need to inference these large neural networks. But it puts a burden on the software. And I think later on we're going to talk about that. But we overinvest in software. We have some of the best and brightest engineers working on our compiler technology to make it seamless to get trained models that, again, we've talked about trained on NVIDIA, but to get them run efficiently on our silicon. And that's really the key to, providing this solution. It's not just come up with a great silicon architecture, but you got to have the software to go along with it.
All right, it's a little bit of a loaded question here. Are you saying that software development then has a greater impact on the success of an AI chip than hardware development?
I do. Because you can have the greatest view in the world, I do where I live, but if my window's cloudy, I can't see it. And software is the window into the silicon. And so if your software isn't getting there, then you've got a real problem. It doesn't matter how good your architecture is. So those have to be defined in parallel, and you want to overinvest in the software side. We have more software engineers than we have silicon engineers, and that's by design. That was an experience I had back in the days doing FPGAs at Altera. We always wanted to overinvest because that's what the customer sees. They don't see, the logic of your processing element and about your FP8 or FP16 ALU. They see your software and how well the software optimizes for the architecture, what feedback it provides the user so they can see, oh, this is how you did it. And they can interact with the software to say, well, I want to optimize this layer, or maybe if I did this, I'm going to get better performance. So that's key.
So a moment ago, you had mentioned that the at-memory compute it helps with the energy efficiency, and energy efficiency is really the king right now because of the power consumption. And power consumption is near and dear to everybody from the responsible AI perspective. Why do you believe responsible AI is important?
I'll split it into two aspects. Let's talk first about what we can influence at Untether, which is the energy efficiency, right? Depending on the projections you hear, data centers consume 1% of the total world's energy, projected to go to 15%. You'll hear sound bites about it takes a lake to cool, these large-scale data centers. So there's obviously a ecosystem impact, and being more energy efficient is better for the planet. AI compute is continuing to skyrocket, so we have to become more efficient in doing that in order to make it happen. Not even just in the data center. Let's take automotive, for example, autonomous vehicles. It's like, every joules that, all the joules we can save means I have better battery efficiency, my car can go longer. It's a better customer experience. So that's critical. Now, something that we at Untether don't influence, but I think, personally is near and dear to my heart, is responsible AI in terms of how the models are trained. Are they diversified? Are they being fair to the entire populace? So I'll give you an example, right? I talked about this recently announced joint development we're doing with Ola Kutram in India. So their vision is to have India-specific large language models, because they feel that India is going to be underserved if it's, left up to the OpenAIs or the AWSs. And their key differentiator is going to be that it's going to be, worked on by Indian engineers. It's going to be trained on Indian data sets, and it's going to support the languages and the idiosyncrasies of the Indian culture. That's key. One of our sister companies, Cohere, they're part of our Radical Ventures, one of our VCs. They have a big effort involved where they're making sure that they're training large language models on underserved languages, sub-Saharan African languages and the like. So that's important, I think, that people, throughout the entire stack understand, and that we're doing the right things.
Wow, no, absolutely. And thanks for bringing that additional perspective as well. And shifting a little bit, so there are a couple of adjacencies or building blocks, if you will, to AI hardware, being RISC-V and chiplets that I believe are going to be central to its continued advancement. How does Untether leverage these technologies to its advantage?
Sure. The two things you mentioned, chiplets and RISC-V, are part of our toolbox. When we sit down and look and decide what are we going to build for our next generation product, RISC-V was a natural choice for us because of its ISA extensibility, so the instruction set architecture. We have a unique architecture. We wanted to add a bunch of custom instructions to be able to utilize our underlying architecture, but also to modify a processor so that it's better tuned for AI workloads and not just general purpose sequential workloads. But we're not necessarily dogmatic about RISC-V. We used it because it was a tool that had this capability that we wanted. But we have a strong partnership with ARM, both on the automotive side and on the data center side. And so in that regards, we're somewhat agnostic. I wouldn't go out there and say I'm, waving the RISC-V flag versus the ARM flag. We use what's pragmatic for us. Same thing with chiplets. The reason we're attracted to chiplets is because they provide energy efficiency, right? Rather than having packaged parts and blasting PCI Express between chips, we look at using UCIe. We're a member of the UCIe consortium. And the fact that if we can put two chiplets together and use UCIe, it's a lot more energy efficient to get the data transferred across multiple chips. And as we look to the future, all of these large language models in the data center, it's a multi-chip solution, even for inference. You're not going to do it in a single chip. And so minimizing that energy consumption for the transfer is pretty important for us and then our roadmap.
Absolutely. Now, earlier you mentioned GM Capital, and you just mentioned the strategic partnership with ARM. What opportunities does this create for automotive OEMs and society overall?
So I'll couch it in a couple terms. You have ADAS today, right? Kind of level 2 plus. I just bought a new car and it's got lane departure warning and it's kind of cool. But we're not quite there yet for the fully autonomous vehicles. And part of the reason for that is that we just don't know, we don't have enough TOPS, tera operations per second, to run the sophisticated enough AI to make these autonomous vehicles bulletproof. And so that's an ongoing development. And so from us, we see that as an opportunity because our energy efficiency in AI, as we look to the future, will all cars be battery, EVs, or will they be ICE? It doesn't necessarily matter, but energy efficiency is absolutely critical. And our partnership with ARM, it aligns perfectly because ARM has always been about energy efficiency CPUs, right? That's how they got into mobile phones, is that it's going to be more energy efficient than an x86 type of architecture. So it's a natural alignment for us and ARM in the automotive because with them and with their CPUs, energy efficient, us with our energy efficient AI acceleration, we're going to be able to jointly provide to these automotive customers, the highest throughput but lowest energy that they're going to be able to get.
Makes a lot of sense. Now, another market that Untether announced to move into is aerospace and defense. And can you tell us why you made that move, and also how your solution is well suited for these applications?
Sure, and that's great. And it's about energy efficiency once again. So I'll give you an example. We just did a blog post on low Earth orbit satellites. So there's thousands of them, and there's going to be hundreds of thousands of them, right? This is not slowing down. But they have a need for collision avoidance, and they have a finite energy budget, right? You put a satellite up, it's solar powered, and you get a certain amount of energy for each trip around the world. And you want to be energy efficient, but you also need to have high response, throughput, low latency. And so those types of companies are looking for energy efficient AI acceleration for that type of application. So that's what drives it. The other thing that I think is unique to us is that we use standard process technologies. You probably heard a little bit about in-memory computing and ReRAM and using flash cells to do compute. All of those types of things where you start mucking about in the process technology, you start making some trade-offs in terms of how reliable and how radiation tolerant you are. Because we use standard CMOS processes, standard SRAM cells, we do all of our innovation in the architecture, not in the process technology. We feel that we'll have a nice rad tolerant solution for these types of satellite applications.
And so that will enable them to be rad hardened.
Yeah, it'll enable them to be rad tolerant. And so we're ongoing with that investigation as we speak. We expect to have some first results here by the end of the year, and then understand, what we might need to tweak as we go to providing a rad tolerant solution.
Makes a lot of sense. Now, bringing it from space back down to Earth, could you give us any kind of sneak peeks into what's on the horizon and some other application space that Untether solutions can make an impact on, and why?
Sure. I can't unveil our roadmap beyond, what we've said publicly, and, it's great timing, as I mentioned. So this morning it was announced, it was, daytime in India yesterday, that we're working with Ola Krutram, and their view is to stand up India-specific data centers for India-specific people and to have a scalable solution. And they've selected us, and we're working with them on that next generation solution. So that's going to be a generative AI solution. If you look at where our technology has been for the first two generations, really great for vision processing, natural language processing, and smaller large language models. But when you start talking about 70 billion, 175 billion parameters, there's some tweaks that you need to make to your architecture in order for it to be efficient for that type of application. And so that's what we're working with them on.
Okay. What are some of the greatest challenges that Untether is facing as far as adoption from some of those new markets or even existing markets, Bob?
Well, I think the biggest it's a challenge, it's also an opportunity, is the dominance of NVIDIA. Right, as I mentioned, 98% of the world's models are trained on NVIDIA, therefore they run on NVIDIA. People who optimize their neural networks for performance, throughput, or latency will write in CUDA code. And you've heard people talk about a CUDA moat. It's not so much a moat as much as it is that, it's what's available to the engineer. When we talk to our customers, they desperately want an alternative. And so when we talked about the software aspect, our challenge and opportunity is to make it as easy as possible for them to take these NVIDIA specific trained models and get them moved to run optimally on our hardware and our architecture, right? And so that's a key focus for us. And that's, like I said, why we overinvest in our software engineering in order to make that happen. And we want to make sure that we provide the same level of tools. I mean, as a startup, you're not going to be as big as NVIDIA. I'm not going to have as big a library of CUDA code that we can provide. But for our specific customers, making sure they have the tools to be able to do things that are analogous to CUDA. So when our customers want to do low-level programming, we enable that. We allow them to do that in C or C++ with a low-level kernel compiler, the same one that we use for our own development of our internal kernel library. So we're mirroring to a certain degree what NVIDIA has, and that's really the opportunity.
Well, this has been a wide-ranging conversation, and really do appreciate the insights. Congrats on the news once again. That's incredibly exciting. Something you mentioned early on in our conversation that's important in an AI company's success, or a hardware company's success, is pockets and being able to dig down. So if an investor, another thing you've mentioned multiple times is a criticality of your engineering force. So whether it be an investor, a customer, or a potential engineer that wants to work for Untether, how would you ask for people to get a hold of you directly or to reach out to Untether?
Sure. Well, I mean, you can always, the website's the best way to go. Anybody who fills out a form on a website, I get an email. And so I direct it personally to the necessary folks within the company. From an investor standpoint, I send that to our CEO, Chris Walker, but I am involved with him on the fundraising. Product related stuff, will go to our sales team. And then, for applications, we have a careers page And that lists a number of our open positions. But as you know, this is your area of expertise. Not necessarily all the positions that you're hiring for are on your website. And if there are people that are interested and feel that they have a good technology or something to offer on Tether, unsolicited applications are always welcome, and we review those and put those into the right hiring manager's inbox.
Awesome. Well, as always, I've learned a lot, and this has been quite a compelling conversation. So, cannot thank you for thank you enough for your time, Bob, and look forward to catching up probably in about a month at the AI Hardware Summit.
Yeah, probably be there. I'll see you then. And I really
All
appreciate
right.
you taking the time, Justin. Big fan. I've been watching your stuff and how your company has grown and these podcasts. So I really appreciate the opportunity.